In this lecture, we're going to start on chapter 2, which is going to go over energy and the first law of thermodynamics. To begin, we're going to go over a review of some mechanical concepts of energy. Energy is an extensive property. It includes kinetic, potential, and internal energy. In closed systems, energy transfer can only occur across a boundary by work or heat. It's the only two ways that energy can cross your boundary. A change in the energy of the system can be from a change in kinetic, potential, or internal energy, or some combination thereof. So it's a quick review of kinetic energy. If energy is an extensive property, kinetic energy is an extensive property. It's the change of energy that is associated with the motion of the system as a whole relative to some external coordinate frame. The change in kinetic energy from state 1 to 2 for mass m so our change in kinetic energy is our kinetic energy at state 2 minus our kinetic energy at state 1, which is 1/2 our mass times our velocity squared at state 2 minus our velocity squared at state 1. Where, as a reminder, it is final minus the initial state. So like kinetic energy, we also have potential energy, and potential energy is associated with your position. It's the position of the system in Earth's gravitational field. The change in potential energy from state 1 to 2. So our change of potential energy is our potential energy at state 2 minus our potential energy at state 1, which is our mass times gravity times Z2 minus Z1. So we're going to actually broaden our understanding of energy a little bit to introduce the idea of internal energy. So internal energy is a change in energy that isn't accounted for by kinetic or potential energy changes. And it's a change in energy that's associated with the makeup of the system, and it includes its chemical composition. Unfortunately, unlike kinetic and potential energy, there is no simple expression for there's no simple expression that's comparable to kinetic and potential energy for internal energy, and you evaluate internal energy using data tables that we're going to get to later. It is an extensive property. Its symbol is a capital letter U. And the mass basis, our specific internal energy, is a little u. On a mole basis, it's a little u with a bar over it. So the total change in energy is the sum of their internal kinetic and potential energy change. So my total change in energy is going to be my energy at state 2 minus my energy at state 1, which is going to be my change in internal energy plus my change in kinetic energy plus my change in potential energy. Only a change in the total energy of the system between two states has significance, since you're using an arbitrary value of the energy at state 1 can be assigned to the system. So there's really no value in saying the energy of the system at state 1 is. You really only look at changes in total energy. You can say the change in kinetic energy is, you can say the kinetic energy at state 1 is, the potential energy at state 1 is, the internal energy at state 1 is, because they all have references that have been arbitrarily been defined, but you can't say that the total energy at state 1 is. That's it for this lecture. In our next lecture, we're going to broaden our understanding of work from what it was defined as from a mechanical standpoint.